All right, so now let's look at finding our z-score in example here. So this example says that the mean speed of vehicles along a certain stretch of highway is 56 miles per hour with a standard deviation of 4 miles per hour. You measure the speed of 3 cars traveling along the stretch of highway to be 62 miles per hour, 47 miles per hour, and 56 miles per hour. And we want to find the corresponding z-scores for each one of these. So first, let's think about what we need. We need our data value, we need the mean, and we need the standard deviation. Okay, so let's see, mean speed, good SAT underlying skills, 56 miles per hour, standard deviation 4, and our data points 62, 47, 56. So let's find our z-scores for each one of these. So first let's think, okay, 62 miles per hour. Is that above or below our mean? If our mean is 56, it's above, which if we go back to our previous video, above the mean should be a positive z-score, right? Above the mean tells us we have a positive z-score. So let's go through and calculate. So our z-score, z equals data value 62 minus our mean of 56 divided by 4 gets us a z of 62 minus 56 divided by 4 gets us a z equaling 1.5. Beautiful, positive. And so that gets us that 62 miles per hour is above the mean, which is what we expected it to be, right? And that it is 1.5 standard deviations away from the mean. Normally when I explain this, I kind of give it as an example of what the z-score does for us. And the best way that I've come up in my couple of years of teaching z-scores is that, so let's say you have two different things. One thing's measured in feet, one thing's measured in centimeters. And let's say you had, 5,000 centimeters versus 100 inches, right? You'd want to be able to compare those, and the easiest way is to come up with some conversion, right? So convert one to the other. You're trying to get things into like the same units, right? And so the z-score helps us kind of transition to a unit that you can compare. Just like if we turn both of those into centimeters, you could tell which one was longer and which one was shorter, right? So the z-score helps us compare different data across different examples. So that's what the z-score does for us. Okay, so let's look at our 47, our next example. Sorry for that little rant. 47 is below the mean, so we should get a negative z-score. So let's see what we get. 47, z equals 47 minus 56 divided by 4, and you should get a z of negative 2.25. So that tells us we're below the mean by 2.25 standard deviations. Lastly, we got 56. We are the exact same as our mean, 56, 56. So if you recall up here, you should get a z-score of 0. So this should come out to be 0. Let's just check it though. Z equals 56 minus 56 over 4, which does in fact come out to 0 since it is our mean. And so we could use these z-scores to help us compare. Let's say we wanted to know a stretch of a highway that the mean was 70 miles per hour. Well, we want to know how many people are going closest to that mean. We could use z-scores to help us determine, which stretch of highway are people driving more close to the mean based on these z-scores. Because if we turned everything into z-scores, you can compare z-scores just like you can compare centimeters to centimeters. And when we talk about comparing, we use the words usual versus unusual. And this is kind of like whether it's like a significant difference or whether it's not. And for us to say if something is usual, right? So usual, that means that it's between -2 and 2 standard deviations. Right, so in this case, if we look up top here, we have that 62 would be usual and 56 would be usual because their z-scores are between -2 and 2. However, for unusual, it's outside of that. right? And so if we look up here, we get negative 2.25. That's outside that range. So we would say that 47 miles per hour is an unusual speed. All right, so that z-score helped us compare that. All right, last thing for this section, the idea of a standard normal curve. We'll get into kind of doing some more work with our standard normal curve. Is just that kind of like that same transition to centimeters. We are kind of changing our units from just like up here. Let's go back here. When we kind of listed off like what each one of the standard deviations are, we want to get to a point where we can only go 1, 2, 3, 4, 5, right? Where we're talking in z-scores. So the only difference here about our standard normal curve is that it has a normal bell shape, right? Our mean is 0. So notice our mean here is 0. And each standard deviation we go out is a unit of 1, right? So we go 1, 1, 1. And we'll talk about next time how this helps us find different probabilities and so on.